Imagine cutting your heating and cooling energy use, maybe even like in half, while your home stays perfectly comfortable no matter how wild the weather gets outside.
Sounds pretty good, right?
Yeah. Sounds like the future, maybe. Well, that's the promise of geothermal systems. We're doing a deep dive today into a whole stack of sources. You shared articles, some research, and even a really fascinating peek into a real homeowner's experience. We want to really understand this technology.
That's right. Our mission is basically to unpack what geothermal is because it's fundamentally different from what most of us have. We'll explore the key benefits, the practical stuff you need to think about, and look at some of the, the latest tech and those real-world experiences.
Right. Ultimately, we want to give you what you need to know if this is something you're maybe considering for your own home.
Definitely.
And as part of this, we'll touch on details from one source that highlights a specific company, Hartzell's Heating and Cooling, down in Oklahoma, and their connection with a manufacturer, Climate Master. It mentioned things like Hartzells, 45 years of installation experience, and them being elite dealers that Climate Master actually states they back 100%.
Ah, interesting. So connecting the tech to the folks who actually install it.
Exactly. Brings it down to the local level.
Okay, so let's start with the basics. What is geothermal heating and cooling? It doesn't use the outside air like your typical furnace or air conditioner.
Right, no big noisy box outside?
Well, not for the main heat exchange, no. Instead, it taps into the Earth's temperature underground. And that temperature is remarkably stable, way below the surface. It stays somewhere between, say, 45 to 75 degrees Fahrenheit, depending on where you live, all year round.
So it's kind of like tapping into a giant natural thermal battery.
That's a great way to put it. It uses the stable Earth temperature as the medium for heat exchange.
Yeah.
The system basically has three main parts.
Okay.
You've got the ground loop, that's the network of pipes buried underground circulating a fluid. Then there's the heat pump unit, usually inside your house. And finally, the distribution system, like your regular ductwork or maybe radiant floor heating, that moves the conditioned air around your home.
Okay, and here's where it gets really interesting, especially for the potential savings we mentioned. One source pointed out a key difference in how it uses electricity. It primarily uses electricity just to move heat, not to generate it from scratch.
That's the core of the efficiency advantage, exactly. The research points out that a geothermal unit typically supplies, get this, 4 kilowatts of heating or cooling for every single kilowatt of electricity it actually consumes.
Wow, 4 for 1.
And here's the part that always gets me. 3 of those 4 kilowatts, they come free, straight from the Earth. You're essentially just paying the electricity cost to run the pump for the fluid and the fan inside. The actual thermal energy itself is, well, natural.
Okay, paying for 1 kilowatt, getting 3 free from the Earth. That 4-to-1 ratio, or sometimes even better, that's a really powerful idea right there. So that energy efficiency, that has to be the main reason people consider making the switch, right?
Oh, absolutely. The potential for, significant long-term savings on energy bills is usually the biggest draw. Some sources suggested you could see bills reduced by up to 50% compared to conventional systems.
Up to 50%. Okay, that sounds amazing. But, listeners are probably thinking, that sounds almost too good to be true. What are the biggest things that drive that kind of saving? And, are there situations where you might see less?
That's fair. The savings come directly from that high efficiency rate we talked about, getting 3, 4, even 5 units of heating or cooling energy for every unit of electricity you put in.
Right.
But the actual percentage you save, that depends heavily on what system you're replacing. Folks using oil or propane often see bigger percentage drops than maybe someone already on natural gas, especially with current energy prices.
Okay, that makes sense.
And critically, how well insulated and air-sealed your house is. An older, drafty house. You won't magically get 50% savings just from the geothermal unit without also tackling those other energy efficiency improvements.
So the house itself, the building envelope, matters just as much as the fancy system.
Precisely. And, the technology itself keeps getting better, pushing efficiency even further. We saw details about Climate Master's V-Flow variable water flow technology, for example.
Wow.
The sources note this specific tech can save 70–80% watts compared to the older fixed speed pumps used in the ground loop system.
Just for the pump?
Yeah, just for the pump that circulates the fluid. But that pump energy can actually be a significant chunk of the system's total electrical use, so cutting that specific part by so much is a major gain within the system itself.
Okay, so beyond the bills, there's the environmental angle too. The sources were pretty clear on this. Lower greenhouse gas emissions, compared to burning fossil fuels.
Yeah, and what's interesting is how direct that benefit is. You're not burning fuel in your house, right? So there are no CO2 or other combustion emissions coming from your heating system directly. You're basically using the Earth's stored solar energy.
So conserving resources, one source actually called them lowest in CO2 emissions among the common heating and cooling options. And then there's just the day-to-day living with it, the comfort. The sources kept mentioning how nice that stable temperature feels.
Yes, because you're exchanging heat with that steady underground temperature, you tend to get much more even indoor temperatures, regardless of, blizzards or heat waves outside. No big temperature swings when the system kicks on or off.
That sounds nice.
Plus, since the main mechanical parts, the compressors and fans, are often inside or the noisy bits are underground, the systems usually operate really quietly compared to, say, a traditional air conditioner unit buzzing away outside your window.
Right. No noisy outdoor fan.
Exactly. And they're reliable even in places with tough climates, like Oklahoma was mentioned, with extreme heat and cold, precisely because that ground temperature stays so consistent deep down.
Okay, so lots of upsides. But of course, we need to look at the practical side, the big one that always comes up first. The high upfront cost.
Yeah, let's be real about that. It is a significant initial investment. There's no getting around it. The main reason is all that underground infrastructure, installing those ground loops.
Oh, pipes.
Right, the pipes. Whether that involves drilling deep vertical wells or excavating trenches for horizontal loops. That's the big difference compared to just, plopping a metal box down on a concrete pad outside your house.
Sure.
One source gave an example from Ontario, I think, citing an average cost range, maybe $30,000 to $40,000, sometimes even more. It varies a lot, of course.
Okay, so that's a serious number to consider up front. What other things, like about your property, affect the cost and whether it's even possible?
Property requirements are definitely key. I mean, not all properties are suitable. You need enough space for those ground loops, for one thing.
How much space?
Well, it depends. Horizontal loops, where they dig trenches, need a fair bit of land, maybe 3/4 of an acre or more, one source suggested. Vertical loops, where they drill straight down, need much less surface area but involve drilling, which can be complex and costly depending on the geology, the rock, and so on. And you also have to consider soil conditions and any local rules about drilling or excavation.
Right. But that big initial cost isn't the whole picture, is it? The sources definitely highlighted ways to offset it, and the long-term view seems quite different.
Absolutely. You have to balance that initial investment against the significant long-term savings we talked about earlier. Those predictable energy bill savings year after year can provide a really sound return on investment over the system's life.
And there are incentives, too.
Crucially, yes. There are often financial incentives. The federal tax credit in the U.S. is a major one right now, and depending on where you live, you might find state-level incentives or even rebates from your local utility company. You really have to check what's available in your specific area.
And the research we looked at also mentioned that these systems can actually increase the resale value of a home. So that's another potential way that upfront costs might pay off down the road.
That's a good point, too. And speaking of the long term, the longevity compared to traditional HVAC, well, it's pretty impressive.
Yeah, I saw that. The underground loops themselves are often quoted as lasting 50 years or even more.
50 years, yeah.
I think one source mentioned that 50-year figure is often tied to the pipe manufacturer's warranty limit. But still, 50 years is a long time for infrastructure.
It really is. And the indoor unit, the heat pump itself, that typically lasts around 20 to 25 years.
Which is still longer than most furnaces or air conditioners, right? Those might need replacing every, 10 or 15 years?
Often, yeah. So you're potentially avoiding 1 or 2 replacement cycles of conventional equipment over the life of the geothermal heat pump.
So longer lifespan, and the sources also mentioned lower maintenance requirements. How does that work?
That's generally true, yes. They tend to need less upkeep because, well, there are fewer moving parts overall, especially compared to something like a furnace that involves combustion.
Makes sense.
And, of course, those underground loop components are buried, so they're protected from weather, storms, vandalism, all that stuff. While traditional systems might need checks a couple of times a year, geothermal usually just needs a regular inspection, maybe once a year.
Okay, so what does that annual check usually cover?
Well, when you get a professional service check annually, they'll typically look at things like checking the coolant levels, maybe visually inspecting any accessible parts of the ground loop system for leaks or damage, though issues there are pretty rare once it's properly installed.
Right.
They'll clean or replace air filters just like any forced air system. inspect the ductwork, check electrical connections, test the thermostat calibration, make sure safety switches are working.
Standard HVAC stuff, mostly.
A lot of it is, yeah. They'll also inspect piping for any leaks or corrosion, and if it's a system that heats water too, they'd check water flow and pressure. But yeah, that annual professional service for inspection, cleaning, and a general tune-up is definitely recommended to keep it running smoothly.
Okay, so you've made this big investment in a super efficient, durable system. How do you make sure the comfort is, like, perfectly tailored room by room?
Good question. This is where newer technologies like zone control systems and smart controls really shine. Zone control lets you manage the temperature in different parts of your house independently.
So, like, I'm not blasting AC into the unused guest room all summer just because the living room is warm.
Exactly. It works using dampers, little automated flaps installed inside your ductwork. These open or close based on signals from local thermostats in each zone, all coordinated by a central control panel.
Okay. And the question often comes up, can you actually do that with geothermal? Can a geothermal system have zone controls?
Yes, absolutely. The sources were clear on this. Because the indoor geothermal unit typically uses a standard air duct network to distribute the conditioned air, any comfort system that uses ducts can usually be set up for zone control.
And one source called out that combining zone control with geothermal's inherent energy saving is, like, a great way to get even more value. You're already super efficient, and now you're only conditioning the specific space you're actually using.
Makes perfect sense, doesn't it? Now, speaking of controls, let's talk about some of the smart technology, particularly from Climate Master, which the sources highlighted as being pretty advanced.
Yeah, like their iGate communicating controls. What makes those controls intelligent or communicating?
Well, it's described as kind of the next generation in HVAC controls because it uses two-way communication. It's not just the thermostat telling the unit what to do. The unit is also sending detailed information back to the thermostat and beyond. This gives you, or more likely your technician, incredible power to configure, control, monitor, and even diagnose the unit. This can happen right at the thermostat through a special computer service tool or even over the internet.
So does the homeowner actually see all that complex data?
The thermostat display itself usually shows key information in plain English, which is nice for the user. But the real power is often on the service side. Dealers can apparently monitor up to 47 different data points remotely.
Oh, wow.
They can see detailed fault codes, including the exact conditions when a problem occurred. And get this, they can even change around 15 different operational settings remotely via the internet using something like a My Uplink account from a smart device.
Huh. Now, why does all that fancy remote tech matter to me as the homeowner?
Well, think about it. It means potentially faster, more accurate troubleshooting, maybe fewer service visits because some diagnostics or even small adjustments can be done remotely by your installer. They might be able to fine-tune your system's performance for optimal comfort and efficiency right from their office, potentially saving you money on service calls and energy bills without needing to physically come to your house just for a minor tweak.
That remote capability, that level of insight.
Yeah, that sounds like a huge benefit, both for me and for the company maintaining the system.
It really is a significant step forward. And this iGate system enables another major advance they highlighted, vFlow, variable water flow.
Okay, vFlow, what's the deal with that?
The sources specifically pointed to benefits like potentially easier and quicker unit installation, which could help a bit with that upfront cost we talked about, plus superior reliability, and, importantly, higher cost savings during operation.
How does vFlow actually save energy then?
Okay, so instead of having a circulation pump in the ground loop that just runs at one constant speed whenever the system's on.
Right, full blast or nothing. Exactly. vFlow uses a variable speed pump or sometimes a modulating water valve that's electronically linked to that iGate control system. It intelligently adjusts the water flow rate based on exactly what the unit needs at that moment, considering its heating or cooling capacity and the temperature of the water coming back from the ground loop.
So it ramps up and down.
Precisely. It works to maintain optimal performance and efficiency across different conditions. And the sources reiterated that this can deliver something like 60–80% lower pumping cost compared to those traditional, constantly running external pumps you find in many closed-loop systems.
60 to 80% lower cost just for pumping the fluid. That's substantial.
It is. And apparently, in many closed-loop setups, it can actually eliminate the need for those separate external pumps entirely.
Okay, so we've talked about the core tech, the benefits, the costs, the controls. Let's shift from the cutting-edge features to the The human experience. One of the sources gave us a fascinating look at what happens when this tech hits the real world through a homeowner's experience shared on Reddit.
Yeah, this was really interesting. It provided a glimpse into the kind of real-world nuances homeowners might encounter. This user was in Connecticut, just installed a brand new geothermal system in a pretty large house, 5,800 square feet, 3 separate zones. They'd converted from oil heat and traditional AC, and they were using Ecobee smart thermostats.
Okay, sounds like a major upgrade. What snag did they run into?
They noticed something odd. In one specific zone, the temperature would take a significant dive. They actually used the word plummet, dropping from 67 degrees down to 62.7 degrees, almost 5 degrees, right when the heating kicked on for that zone.
Ouch. 5 degrees down when you want heat sounds unpleasant.
Yeah, and because of how their smart thermostat was set up, this big sudden drop immediately made the system think it needed to work extra hard. So it would jump into stage 2, that's the higher capacity heating mode, and run longer to try and recover that temperature quickly.
Okay, that sounds uncomfortable and probably inefficient if it's constantly overshooting because of that initial drop. What were people in the thread suggesting might be causing that?
There were a few interesting possibilities discussed. One common idea was cold air just sitting stagnant in the ductwork, especially if those ducts run through unconditioned spaces like an attic or a crawl space.
Sure, that happens.
Another thought was maybe the system's fan was starting up and blowing all that cold duct air into the room before the geothermal coil inside the unit had fully heated up.
A timing issue.
Could be. Thermostat placement was also brought up about, is it too close to a supply vent blowing cold air initially or maybe near cold air return? One user even shared a story about how finding a thermostat wire that had been run through a return duct was causing weird readings for them.
Huh. Little details matter.
They really do. They also considered the house's overall air leakage and insulation, maybe drafts, but the homeowner felt their energy monitoring data didn't quite point to that being the main cause for that sudden drop right when the system turned on.
Okay, so what kind of troubleshooting ideas were floated? How could they fix that plummet?
Ideas bounced around included things like adjusting the temperature differentials on the thermostat, basically, telling it not to panic and jump to stage 2 quite so quickly just because of that initial dip.
Oh.
Another suggestion was to keep the system's fan running on a low speed, either continuously or maybe just for a set time each hour, like the user tried setting their Ecobee fan to run 10 minutes per hour just to keep the air circulating gently and prevent that cold air from pooling in the ducts.
Keep things mixed.
Right. Using remote temperature sensors placed away from vents or potential draft spots was another idea. And of course, verifying the overall ductwork design and confirming the thermostat wasn't in a problematic location relative to the airflow.
So it really shows that even with these super advanced high-efficiency systems, sometimes the issues you encounter are related to, well, simple things like air distribution or control settings.
Exactly. It really highlights why working with experienced installers is so important. You need people who not only understand the geothermal technology itself, but also how it integrates with the unique characteristics of your specific house, the structure, the existing ductwork, all of it, and who can help diagnose and sort out these kinds of real-world nuances.
And speaking of experienced installers, this brings us right back to that local focus we saw in our sources. We saw those mentions of Hartzell's heating and cooling.
Yes. The source specifically mentioned Hartzells as a company providing professional HVAC services, covering everything from routine maintenance to immediate repairs for home comfort needs.
And they're based in Oklahoma.
That's right, specifically serving central Oklahoma, and the source listed several counties: Kingfisher, Logan, Canadian, Garfield, Major, and Blaine County. So a pretty wide service area there.
And crucially, the source didn't just name them. It highlighted their specific experience and their partnership with Climate Master, the manufacturer we were just discussing.
It did. It noted they have 45 years of installation experience. That's a long time, especially for technology like geothermal that involves complex underground work and system design.
45 years, yeah. That's significant.
And it also explicitly stated they are elite dealers for Climate Master. And, importantly, that Climate Master, the manufacturer, will back Hartzell's installations 100%.
Okay, so that really connects the dots, doesn't it? You've got a manufacturer known for these advanced systems like their Trilogy and Tranquility lines, or the iGate controls and vFlow technology we talked about. And then you have a local installer, Hartzell's in this case, with decades of specific experience installing these systems. It suggests they have the capability for the whole process, the design, the installation, which might involve drilling depending on the loop type, the ongoing service, handling warranties, and providing that guarantee, all with strong backing from the manufacturer.
Precisely. For you as a homeowner thinking about geothermal, finding those local experts who have that kind of proven track record, deep experience, and a strong relationship with the equipment manufacturer, well, that seems pretty crucial for making sure the system is designed right, installed correctly, and performs the way it should for, decades to come.
Well, we have certainly dug deep today. Geothermal heating and cooling. It's clearly a really powerful technology, super efficient, environmentally friendly, offers that potential for significant long-term savings, and really consistent comfort.
Yeah, even with acknowledging that higher upfront cost barrier.
Right. And it's not standing still either. It's constantly evolving with things like smart controls, like that iGate system, and advanced variable flow technology like vFlow, pushing performance, installation ease, and efficiency even further.
And as that real-world example showed us, understanding the little nuances, carefully considering your specific property, and critically, working with skilled, experienced professionals for both the installation and the long-term maintenance, that's really key to actually realizing all those benefits we've discussed.
It definitely gives you, the listener, a lot to think about if you're exploring long-term solutions for your home's comfort and energy footprint.
So maybe a final thought to leave you with. As you consider potentially adopting technologies like geothermal for your own home, how does understanding all these details, from the basic physics of using the Earth's stable temperature to the nitty-gritty of smart system controls and variable flow pumps, to the practicalities of troubleshooting a real-world comfort issue and recognizing the vital role of experienced local installers with strong manufacturer ties, how does having that deeper knowledge empower you to make the best, most informed decisions for your own comfort, your energy independence, and your future investment?